I know that there are many interesting sessions now, so I'm really happy that you have chosen this one. It will be a bit different than usually this kind of session. I hope it will be a bit different. You will tell me after 1 hour. So the agenda for this session is quite simple. In fact, we have got only 2 points. So first of all, this will do a small introduction to serverless. Some of you may be familiar with this concept. Some of you may not be familiar. So we'll spend about 10 minutes on describing what it is. And then this will be the most important part of the session. So we will try to build real application from scratch. So we'll go to the cloud and we'll build something. It will look more or less like this, that we'll spend 50% of the time on slides, probably less, to be honest, maybe 20%, and the rest of the time really building something. We have got about 45 minutes. We will be using about 7 different cloud services to build this application, and there will be 5 steps. So on each of those steps, we'll be extending the application. So at the beginning, it will be quite simple. Then we will add something, then we will add something, and so on. So 5 steps. Let's hope we will make it in 45 minutes. So the cloud. I'm from AWS, Amazon Web Services, so the cloud provider. And very often I'm talking with different kind of companies, and there is this question, what is the cloud? And very often people believe that the cloud is just a fancy name for a data center. Just a fancy name for a data center which is somewhere, which is operated by somebody, but it's just normal data center. I believe that this is not true. This is my opinion. I believe that the cloud is this. The cloud is Lego blocks. So we go to the cloud, depending, AWS or different cloud provider, and we just pick up those Lego blocks which we will use to build application systems. Sometimes those will be servers, sometimes this will be artificial intelligence, and so on. And this is the beauty of the cloud, because we have got a freedom of choice. It's not only about data center, about servers. And of course, there is this one simple, really boring service, which is called server. And we can go to the cloud, we can try to treat them as standard data center, and we can build application, application system, castle, and it will work. We were doing this for the last 20, 30, 40 years, and it was just working fine, so it will work also in the cloud. But maybe there is a different way, maybe a bit better way, depending on the context. And in the cloud, there are different Lego blocks, different services. So now in AWS, there is more than 100 different kinds of Lego blocks which we take, and we're building from those Lego blocks something. Maybe we need to have some kind of database. Sure, we could go with the server. We are spinning the server, we log in, we install database, and it's running. But maybe we would like to do it much faster, so we will just choose a Lego block which is providing database, maybe MySQL, maybe Oracle, maybe SQL Server, and so on. And this is the cloud. So those Lego blocks, those different Lego blocks, thanks to which we probably will build these application systems maybe faster, and maybe it will be a bit better. So there is this concept of serverless, and what it is. So if you will look at the cloud, there are cloud services. So those are those Lego blocks which more or less I described. So for example, there is EC2, which is a server in the cloud. There is EBS, which is a storage in the cloud. Inside this group, there is a managed services, like RDS or Elastic Cache. So I'm going to the cloud and I'm saying, I want to have Redis, I want to have Memcache, I want to have MySQL, and so on, but I don't want to manage server. I'm not interested in this. Please give me MySQL and so on. So then there is a Lego block which provides this kind of functionality. We still see the server, but we don't have access to it. The user has got only access to to the application, to the database, to the cache, but not to the server infrastructure. And inside of this group, there is a group which is called serverless services. So this is going one step even more. So we are saying we want to have a database, but we don't want to work with servers. I know that there will be servers, but I don't want to see them, I don't want to patch them, I don't want to think about them. And currently in AWS, there are different services which provide this serverless application, serverless functionality. And why is it so popular? Because let's say we are building application, application, whatever. And usually, like always, we will have got this development phase. So we'll be building something, and this is cool, we are building something new, something, fun. And then at the end, everything is done. We would like to go into production, but we can't because there is this boring stuff. So this is my term for this. And this is, what kind of infrastructure do I need to have? Who will be managing? And so on, and so on, and so on. And then after we will answer those questions, there is a go live. Yes, everything is on the production. Everything is working just fine. We are really happy. We would like to go back, to modify this application, to add new features, to do something else, but we can't because there is even more boring stuff. Again, this is my term. So, again, the infrastructure. Our application is there, it's running, but every 1 week, every 1 month, we need to go there. We need to patch Linux, we need to patch Windows, and so on. We need to think about, how we'll scale it, and so on. So there are this kind of questions, usually connected with infrastructure, which we need to, answer. And probably most of us, I know, but I'm not saying everybody, we don't want to do it. So there is this concept of serverless. And in short, it means that something like this, that we as a customer, as a user, as a developer, we are not interested in infrastructure. Here is my application, here is my microservice, here is my database, dear cloud, here it is, manage this, scale this, patch this, do everything. I'm really not interested. I want this to be running 100%, and I want to focus on my business. And in short, this will be the serverless. So AWS currently has got quite a lot of serverless service, and the most popular, the most famous will be Lambda. So for me personally, Lambda is the best service in AWS because it's completely changed the way how we are building application system. So the easiest definition of the Lambda will be that this is a microservice without a server. So we are building some kind of microservice, but we are not thinking about the infrastructure. So in short, what it do is, how does it work is that we are going to the cloud, we're putting a piece of code. This can be written in Java, Node.js, Python, .NET Core, and now it was announced Go. So we are writing this, this microservice, we're throwing it to the cloud, and we are saying, dear cloud, manage this. And because the cloud is managing this, there is a couple of interesting features which are then provided by AWS. First of all, it's scaling. So if there is our microservice, our Lambda, and if there will be one user, AWS will spin up one instance of our microservice. If there will be 3 users, we don't need to think about this. AWS will spin up 3 instances. If there will be 10,000 of users, because our application is really popular, then AWS will spin up 10,000 of Lambda instances. We didn't need to configure it, we didn't need to do it. But the coolest thing is that if there is nobody, because everybody are sleeping, maybe we are building startup, maybe this is the middle of night, 2 a.m., and really nobody wants to use our application, there won't be any Lambda, so there won't be any cost. And this is the coolest thing about this, because if we will have got a server, maybe it doesn't do anything, maybe nobody use the server, but if it's there, you will need to pay for this. So there is also different things which are being done by AWS, because we don't have access to servers, we don't see the infrastructure, scaling, deployment, monitoring, and so on. Those are things which will be done by AWS. And when we have got this kind of microservice, probably we want to execute it, invoke this. So there is a couple of different ways. One of them is use SDK, which is provided by AWS, to Python, Java, .NET, about 10 languages. The other thing is that usually very popular is that we want to expose our Lambda function as a RESTful web service, and then we'll use API gateway, and we'll do this later in one of the steps. We can, of course, invoke our Lambda from different Lambda. We can schedule Lambda that AWS will run it, invoke it every 10 minutes, every 10 hours, and so on. And usually Lambda will be the brain of Alexa. And we also will do this on the 5th step of today. So now we will jump, and I will try to build the application. I will be using code which I already prepared, and it's under this link. on the last slide of this presentation, it's again there, okay? So you can make the picture there then. So the purpose is that, you can take this code and you should be able to do everything what I will do now by yourself, later in your home. Okay, so step 1 of this task will be let it speak. So we'll be using 3 services besides Lambda. Text-to-speech. So if you will look into, the text-to-speech functionality, if you want to provide text-to-speech functionality, it's not easy because it's not only about reading letters, reading words. Because, for example, we could have sentence like this: I live in Las Vegas versus this presentation broadcast live from Las Vegas. The same word, live, but depending on the context, you will read it in a different way. Or maybe something like this, like ST. Again, depending on the context, this will be street or maybe saint. So you need to understand the context to be able to know how to read it. Or maybe, like English words like do, through, and so on. The ending is the same, but again, you will read it in a different way. So it's really not easy to read letters, read sentences. So AWS last year released a service which is called Amazon Poly. And in fact, this is a service which was created in Poland, in Gdańsk. So if you know, there was a company which was called Ivona Software, which was bought by Amazon a couple of years ago. And now they did this service, so Amazon Poly, which provides text-to-speech functionality. So in short, this is a black box. You are not interested in this. You just provide a text in about 25 languages, also in Polish. And then the output of the service will be audio file. The second service which we'll use is S3, and probably S3 is the most popular service in AWS next to EC2, so next to servers. So in short, this is a storage. So we just put data there and it's just growing. So if you are using Dropbox, so the Dropbox outside of USA is using S3 and for storing customer data. The third service will be Dynamodb. And Dynamodb is a NoSQL database, like MongoDB, like Cassandra, but it's serverless. So we don't think about servers, we don't think about the infrastructure. We're just saying to AWS, I want to have a NoSQL database, and after 10 seconds it's there, and we can start working with it. Okay, and so the first step, the first application will look like this, the first stage of it. We will have a document. So this will be a text which we want to convert into audio file, a flat file. And then we want to put it on S3 because this is our storage, data lake, and so on. So whenever we will put this file here, then we want to execute our Lambda function, our microservice. So we will build a microservice which we will call convert to audio. So whenever there is a new file, this will be fired automatically. This is our microservice. It wants to convert text to audio, so it will use a service which is called Amazon Poly to convert it. So now we have it audio file. So now we will also log this information inside Dynamodb because we want to know what is happening and so on. Maybe later we want to see exactly which files were converted. Okay? And the last thing will be that we will take this audio file and we'll put it back to S3. Okay? So this is the first step of the application which we'll do today. Let's hope it will be working just fine. Okay. So for those of you who don't know, this is AWS console. So this is the way how we interact with AWS. So here what we see this is the list of those Lego blocks, of those servers, of those services. So EC2 is a server, S3, and so on. So now we'll use S3, we'll use Lambda, we'll use Dynamodb, and that's for now, this is all. So in S3, we'll want to put those flat files. So let's create a bucket. A bucket is a place where we'll be putting those files. So let's call it Code Europe. Okay, so I have got a bucket here. Okay, and let's create a folder which I will call it text. So whenever I will have got files, I will be putting them here. So there is a text. Okay, so let's go inside Dynamodb. So I also want to have this database where I will be putting those information about those conversions. So we want to create this database. It's about creating the table. So database table in this context will be the same. So let's create a database. I will call it Code Europe DB. And because this is a NoSQL database, so we don't need to define schema, but we need to provide the name of the identifier of the item. So in this case, it will be name. This will be the name of the file which I will put on S3. Okay, so let's create it. And that's all. In about 10 seconds, the database will be created. Okay, so now let's go to Lambda and let's create this microservice. So let's create a function and let's call it convert to audio. So runtime, I will use Python 2.7. Role is a permission. So this, I will choose a permission which I already have created before. So thanks to this permission, the Lambda will have got access to Poly, to Dynamodb, to S3, okay? So let's create it. Okay, and this view is the everything which you need to do, which you need to do to create this microservice. So the first thing is that you want to invoke this Lambda whenever there will be a file on S3. So we need to have a trigger. So we want to analyze, on the left side, we have got different services which we can connect with Lambda. So now I will use S3. So I'm saying to Lambda, analyze S3 and analyze my bucket, which name was code Europe, because this is what I have created. Whenever I will have got a new file, so put a new file in directory text, because I have created this folder text, and this will be a flat file. So let's say it will be txt. This will be my trigger. So let's add this. Okay, and below, I will specify my logic, my business logic. So this is the part which I already have created before, and this is on the link which I provided at the beginning and at the end. So I have got a Lambda which is convert to audio. And this will be the longest Lambda today. The other will be much easier, it's simple. I will make it a bit bigger. Okay, do you see a bit at least? Do you see it? No. Okay, I will just describe it in a couple of sentences because it's not the main point here. So this Lambda will be invoked whenever I will have got a new file on S3. And the logic is working like this, that at the beginning, I'm just retrieving the name of the file and the name of the voice. I didn't say anything about the voice. So Poly, whenever we are converting text to audio, we can specify the voice. So the voice will say which language is it, and in each language we can have different voices, like male voice, female voice, and so on. So on S3 I will also have got, now I have got a folder text, and then I will create a folder with the voice. So now I'm just, getting those information. I'm just logging this just to be sure that, everything is working just fine. Then here, I'm taking the file from S3, and I'm getting it to the local storage on Lambda. Then I'm reading the file, and here's the most important part. So I'm connecting to Poly. I'm connecting to Poly. I'm saying I want to create MP3 file. With the text is the file which I have, taken from S3. And I want to use the voice which I already have retrieved. And then I'm getting the audio file. I'm using the standard Python piece of code, which is creating an audio stream, so MP3 file. And then I'm taking this file and I'm putting it back again on S3 in folder audio. So we will have got a new folder on this bucket audio. And then I'm connecting with the database, so this Dynamodb database. And I'm putting there an item which will have got 4 attributes. So the name, because this is my identifier, so this will be the name of the file, the text which was converted, voice which was used, and URL, so the link to the audio file. And there's a parameter which is called dbName, because now our Lambda doesn't know anything about our database. So we need to tell it, which database are we using. So I will specify a parameter, dbName, and its name was code Europe DB. Okay. There's also some other parameters. Let's don't modify them. I will just extend the timeout. So one of the important things about the Lambda is that single invocation of the Lambda can last up to 5 minutes, okay? So if we have got a logic which is working more than 5 minutes, Lambda is probably not for us. We can also decrease this amount. Let's say 1 minute is more than enough. Okay, so let's save it. And that's all. So if everything is working now fine, whenever I will put a file on S3, Lambda will be executed. So let's see if it's working. So let's go back to S3. We have got a folder text. I will make it a bit bigger maybe. So now I will create a folder with the voice. So the English voice, one of the voices is, for example, Joanna. So let's create a voice, Joanna. Okay. And this is the place where I will be putting the files with, in English, in short. So I have prepared before already some examples. So let's say this one. Great to be here. I think this is working. This is really this file, or maybe a different Lord. So this is the beginning of the Lord of, trust me, this is the beginning of the Lord of the Ring. So I will put it there. So upload. I will just upload it from the browser. It will be just easier. Okay, so the file is there. So now if everything was working just fine, our Lambda should be executed. It should create MP3 file. It should send the information to Dynamodb, and it should have created audio file. So let's go first to Dynamodb. So items is the place where we can see, what kind of informations we have got there. And we see that there is one item, the one which I have created, which have got 4 attributes. So the name was Lord. Text, so this is the beginning of the file. This is the link to the audio file, and the voice, Joanna. And also, if I will go now to S3, I will go to my bucket. So I will refresh it. We have got a folder audio, and we have got a file, MP3, Lord MP3. So let's try to see if it's working. Can we make it louder? The sound? It will be quite useful. Stop here. It will be quite useful to have voice. Now this will from this. We heard it there, so the voice was there. A czemu normalnie przez HDMI powinno właśnie wychodzić? Nie, w Krakowie działało to i to. Ja mogę to na razie wyłączyć, ale powinno być tu i tu. Ja na razie to wyłączę spokojnie. I mówisz, tutaj jest dźwięk, tak? Nie, to później. Sorry, guys.
The world has changed. I feel it in the water. I feel it in the earth. I smell it in the air.
Okay.
Much that once was is lost. For none now live who remember it.
Okay, so the audio file was created. Okay. So cool, it's working fine. So our application at this stage is working. So we can also go to the Lambda, and in the monitoring, we can also see that our Lambda was invoked one time, and it was working just fine. Okay, let's go back to our presentation. So the first step is done. Okay, so we have done this. Okay, so the next step will be let it see. And we'll use a service which is called a recognition. So this is a service which will analyze pictures. So for example, we could put there an image of a face, and it will tell us, is it a male, female, how old is she, is she wearing glasses, and so on. So what we want to do now is we will extend this application. So when we want to extend it by having the possibility to put pictures in S3 bucket. And then whenever there will be a new file, a picture, we want to execute a new Lambda, a new microservice, which will analyze the image. And this Lambda function will be using Amazon Recognition Service. And then it will create a file. a file with the description, and it will be put it again on S3. So the first, logic which we already have created will work. Okay. The pictures which we'll be putting, it will use the recognition for detecting celebrities. So if we put a picture of the Brad Pitt, it should tell us this is a Brad Pitt, and so on. Okay. So let's try to do it. Okay, so guys, let's go to S3 bucket again. So now I have got two folders, audio and text. Let's create a new folder which we'll call images. So I want to put pictures here. Let's go to Lambda. And let's create a new function. Okay, analyze image. Python to 7, Lambda full access, so permission to have to everything. Let's create it. And again, we need to have a trigger. Again, this time it will be like before S3. So the bucket will be code Europe. Again, we'll be interested only in new files, so put folder images and suffix JPG. Okay, so the trigger is already done, so now the code. And this time it will be much easier, to be honest, shorter. Okay, so again, this microservice will be executed whenever there will be a new picture. Do you see the code or no? Because do you see the code? Okay. So this code will be executed whenever there will be a new picture. Again, at the beginning, I'm just trying to retrieve the name of the bucket, the name of the file itself. And then this is the most important. I'm connecting with recognition. And I'm telling during recognition, there is an API, recognize celebrities. And I'm saying my picture is in this bucket, and the name of this picture is, this key. And then I'm getting the information, who was it? I'm creating a text. I see the name of the celebrity on the picture. I'm creating a file, and I'm putting it back on S3 on folder text and Joanna, because the text was in English, so it would make sense to put it there. So let's no parameters. Let's just extend the timeout to 1 minute again, just to be sure. Let's save it. Okay, so now everything should be working just fine. Could you suggest me the name of some kind of celebrity? Yes? Anybody? Come on, guys. Who? Okay, so I guess the recognition will tell that this is Terry Pratchett or Santa Claus. I'm not sure. We'll see. Person. Okay. So let's go back to S3, let's go to images, and let's upload there this file. Person. Okay, so now if everything was working just fine, it wasn't me. Really? Okay, I'm not connecting it. I will try to connect it. Oh, okay. Okay, so now we have got this person. So now if everything was working fine, first of all, we should see in a text folder in Joanna a new file, person.txt. So if we'll try to open it, I see Terry Pratchett on the picture. It's working. And also we should have got in Dynamodb this information. I see Terry Pratchett. And we'll also have got our audio file. So audio person. Okay, so it's working fine. So the next step. Okay. So the first step will be make it RESTful. So now when we are interacting with our application, we are putting something on S3, we are getting something from the S3, but maybe we would like to have some kind of web service, website and so on. And we'll use a service which is called API Gateway. Again, all services which we are using are serverless. And in short, this is a way to create an API, a RESTful API. So in short, we are defining our API. And for example, we are saying, whenever the user will access our page, and he will provide some information, so whenever he will execute HTTP GET method, then he should be redirected to our Lambda function, because there is our business logic. Or maybe we also want to, to connect with different HTTP method like post, put, and so on, and connect it with different Lambda function. So how we will want to extend our application now is that we want to use a browser to be able to listen to the audio files which we have converted. So we'll use API Gateway, and we'll create a Lambda function which we'll call getData, which will be connected to Dynamodb. And in short, it will be working like this, that here I will provide the name of the file, which I already have converted. It will be sent here, it will be sent to Lambda. Lambda then will look in Dynamodb the item with this name, and then it will get the audio file, and it will send it back to the user. So let's try to build it. Okay. Let's go to Lambda again. Let's create a new Lambda function. This time it will be get data. Python again, full access. Let's create it. Again, we need to have a trigger. This time it won't be S3 because we don't want to invoke it whenever something will happen on S3. We want to connect it with API Gateway. And we will say that our API will be called Code Europe Tomek. It will be production, and let's make it open so everybody will be able to auto-access it. So let's add this trigger, and let's now specify the code, so the business logic of our microservice. This won't be the best practice, but this is working, so that's why I wanted to put it like this. Usually, using RESTful web services, you would return some kind of data, JSON or something like this. This time, I wanted to return the whole web page, so that's why I'm returning here HTML. So I'm rendering the page. In short, how this will work is whenever it will be here, it will get from the query string parameter the parameter with the name. So this will be the file which we want to retrieve. Then we'll connect with Dynamodb we need to provide the name of this database. We will look for the link URL to S3 audio file inside this database. And then we will return HTML with audio tag, and the link to the audio tag will be the link to the audio file. So we just need to fill out this parameter, so database name. So DB name is Code Europe DB. This was here? No, this was here. Again, let's extend it to 1 minute. Mac. I hate Mac. Examples, Polish. Okay, so now it executed the Lambda from converting to audio file. So now let's go to our API gate, our RESTful web service. Let's say Polish, because this was the name of the file.
W trzęsawisku trzeszczą trzciny, trzmiel trze w trzciance trzy trzmieliny, a trzebyczki znad trzebyczki z trzaskiem trzepią trzy trzewiczki.
Okay. Yeah. I could do it better. Yeah, but sure. Okay, guys. So we have exposed it as a RESTful web service. So 3 steps and tomorrow. Oh my god. Okay. So next, notify me. So now, whenever we have converted this to audio file, we are not getting any information. We can go to audio S3. We can see, yeah, it's there. So we'll use a service, really simple service, which is called Simple Notification Service. And in short, it's working like this, that we are creating a topic, and we can create different subscriptions. And whenever we will send a message there, then SNS will, fund this message to all the subscriptions which we have created. So we want to extend our application like this, that whenever there will be a new item inside our database, we will use we'll create new Lambda function, send SMS. It will connect to SNS service, and it will send us SMS and maybe email. So let's do it. So let's go to first SNS. So this is the place where we configure these notifications. So to topics, and let's create a new topic. So this will be CE. Let's go there, and I will make subscription. So first, here we have got this list of different options. So first of all, SMS. So this will be my number. And maybe let's also create an email subscription. So, okay. So now whenever I will send here a message, it will be sent to SMS, and to email address it can't, because there's a pending confirmation. So I need to confirm on my email box that this is my mail. So I will just log into this is my mailbox. So I just got an email asking to confirm this is you. Let's confirm it. And now on SNS, if I will refresh it, I have got information that those subscriptions are okay. Cool. So let's go back to our Lambda, and let's create a new Lambda function. Let's call it send SMS. And this will be Python, full access. Let's create it. So now I want to invoke it whenever there will be a new item inside the database. So inside the trigger DynamoDB, I want to analyze my code EuropeDB database. Whenever there will be a single new item, I want to invoke this Lambda function. So add, let's save it. Okay. And now the code, really easy one. Okay, so I'm just connecting to SNS, so Simple Notification Service. I'm sending there a message. As the message will be sent, this will be the link which was put it on DynamoDB, and the topic RN is the identifier of my topic which I have just created, and this is this. So this is Amazon resource number. So I will create a parameter with the value this. So SNS topic. Let's extend it to 1 minute. Let's save it. Okay, now everything should be working just fine. So let's try to put there a new file. I think I don't have any more examples, so we need to create a new one. English. Okay. Great to be here. Yes. I'm here. Okay. So this will be my file. Let's go to, this will be English, so let's go to Joanna and let's upload it. Okay. Okay, so now it has sent audio file is being converted. So we can go to audio, and there is an English MP3. And I just got SMS, so let's try and see if it's the audio file.
Great to be here. Yes, I'm here.
And I also got I should also got an email. Yeah, there's an email with the link to the audio file which we have converted. Okay, we have got 7 minutes, yeah? Yeah. Okay. Okay, so guys, the last step will be, let's talk to it. So now we are interacting with our application by putting files on S3, and we're just getting information by email, by SMS, and so on, by web page. But maybe we would like to talk with our application, and maybe we would like to use Alexa. Alexa is an artificial brain which was created by Amazon, and it's short.
Sorry, I'm having trouble understanding right now.
Now internet is not
Please
working.
try a little later.
So this is a small version of Alexa. Alexa, how are you?
To be honest, it's been kind of a rough day.
I didn't plan it really. Okay, so whenever it will hear her name, it will wake up and it will do something. And you can build your own skills or your own application on this. So whenever you have got application, my application, you could say, Alexa, ask my application, blah, 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 to do something. Also, inside there's Alexa and some, for example, Ford is now putting Alexa inside their cars. So whenever you are driving your Ford, new Ford, you can say, Alexa, I will be home in 10 minutes, do something. So Alexa is not a part of AWS, so we'll be using a different portal, developeramazon.com. And we want to extend our application by having something like this, that we want to talk with our application. And by talking, we mean by Alexa. And we will build a new Lambda code, which will be connected with Dynamodb. So in short, I want to achieve something like this. I will ask Alexa, ask my application to read me Lord, to read me Polish, and so on. And then it should connect it to this, and Alexa should read me the file which I have already converted. I already did a part of this before because I was afraid that we won't have enough time, and we don't. So I will show you how does it work. So this is at developeramazon.com. I have got my skill. A skill is the application on Alexa. So I will go there. Maybe. Maybe no. 5 minutes. Okay, so in Lambda, we'll create a new Lambda function. I will call it Alexa integration. Sorry, from blueprints. There is already one created. Python, Alexa. Yeah, let's use this one. Alexa integration. Role Lambda full. Okay, so those are my skills. There's a cloud book. This is one which we'll be using now. And in short, we will connect it. Whenever I will want to talk with this skill, I will need to say cloud book. Because this is the name of my skill, and we want to configure it with our Lambda. So configuration, and here we'll put the endpoint ID of my Lambda. So let's go to our Lambda. I would just need to provide the code because it's not correct. So in short, it's getting the name of the file. It's looking inside DynamoDB, the item with this name. It's getting the link, the link to audio file, and then it's returning speak, audio, and the link to the audio file. So I just need to provide the name of the database. So code. Okay, extend it to 1 minute. Let's save it. And this is the identificator of my Lambda. So inside of skill itself, I'm saying connected with this backend. Save it. Okay. So now if everything is working class. Alexa, ask my cloud book to read Polish. I need to check how did I activate it because I don't remember. Alexa, ask cloud book read Polish book. Alexa, stop. Alexa, ask Cloudbook who is on person picture. Alexa, ask Cloudbook who is on person picture.
I see Terry Pratchett on the picture.
Okay, so it was working. Okay, guys, the last slide. Wait. Guys, the point here, cloud is Lego blocks, okay? We just took this Lego, this Lego, this Lego, we have connected those, and we have got application. Maybe this is not the most advanced application in the world, but also it's not the easiest application in the world. I think you would agree with me. So yeah, so when you think about the cloud, think about the Lego blocks, okay? So it's really playing with Lego. So there's a link to the code which I have used. And yeah, thank you for being here, really. Thanks.